Aaron, are you guys done?
Oh, we're done with number 6.
Yeah, we're done.
So right
I don't know.
So which was small enough?
I think you guys were group 6, but problem 5.
Oh, I thought we were 10. I don't know why.
So 1, 2, 3, 4, 5, 6. And way over there.
Alright, so 5.
I need to see how to get there.
Those cancel out.
So guys, you should be writing up your strategy on the whiteboard so I can see what I should be putting up. Okay, that we clear the Lord for the last one. Alana, do you guys have something written?
No, like 10 before. Not even. Where's the secret in the fourth program?
For yours, you guys took. Kira, what was the strategy for your first step in your group?
I left canceling the cosine and then broke the tangent into the cosine of sine to cancel out to get sine.
Let me see that first step. I heard a lot of.
Doing this. Oh, I did.
I did that too,
group
actually.
sixes instead of.
There's a plus in between those, so
Okay.
some stuff doesn't quite cancel. Do you guys have a start? Okay, all right. So everybody's kind of that's got problem 6 is a little bit stuck. So let's look what group 1, 2, 3, and 4 did. They're seeing secant squared was in both lumps. So if I take secant squared out of both lumps, what's left inside is 1 plus tangent squared. Consulting the packet, 1 plus tangent squared equals what? Secant squared. Like that's what the identity says on the sheet that you have. So we're getting rid of this and putting what that equals. Secant squared beta times secant squared beta, Muhammad, becomes what? X squared times x squared becomes, nope, doesn't become 1. No, x squared times x squared. X to the 4th. So secant squared times secant squared becomes secant to the 4th. And don't lose the angle. Hold on. Are you guys okay with that? And where you know?
Like, I don't understand how you get secant out of secant squared plus tangent.
Where'd you put the tangent on?
Yeah, I know, but like.
Okay.
Oh, wait.
The very first step was factor out secant squared.
I got that. Like,
So it looks different, but can I take an x squared out of both of those guys? What's left inside?
it's a plus y.
Okay, so here, one times secant squared, when I take secant squared out, it's 1 plus tangent squared. So checking the identities that you guys have on the front of the packet, the one that has tangent squared says tangent squared plus 1.
Oh, I got it, equals secant squared, yep.
So I took that more complicated lump, 1 plus tangent squared out, and put its equals in.
Yeah.
Okay, then this middle group, they said sine was attached to both of those. And then they got a complicated thing. The identity they need to look at, sine squared plus cosine squared equals 1. Luca had the challenge. Cosine squared x, wants that as positive, so he subtracted 1 from both sides, and he subtracted the sine squared. That's the hard thing to see, because it's backwards. It's not 1 minus cosine squared, but cosine squared minus 1. So this got replaced with negative sine squared x. Yes, no? Eleanor, what's the question? Do that again?
Yeah.
Okay. Can I erase the first one? Just because it's getting confusing with all this stuff on the board. All right, so Eleanor, what we're doing, sine squared plus cosine squared equals 1. I want something that says this. So I don't want sine squared with the cosine squared, I'm gonna move it. So over here I get cosine squared x equals 1 minus sine squared. It's not quite right. Subtract 1 from both sides. I get cosine squared minus 1 equals negative sine squared x. So I'm gonna pick up all of this, take it away, and plug in what I just solved for, which is negative sine squared.
Is the answer for 6 secant x?
Okay, let's check. So number 6, what factors out of both pieces?
Cosine.
Cosine. So when I take cosine out, Valentina, what's left in when I take cosine out of both lumps? Tangent squared theta plus 1. Hey, there's an identity for that. Emma, tangent squared theta plus 1 equals what? Secant squared. So that's cosine theta times secant squared theta. But Ivan, it feels like there's something else that can go on. What can we do?
Secant squared is cosine squared.
Okay, so then Angel, what happens?
They cancel.
One of the cosines cancels out. So this cosine and one of those guys. So Danny, I end up with 1 over cosine. What's another name for 1 over cosine? Okay? They're just little puzzles. Fun. I like them, they're fun, they're like fine, sourpuss. Okay. Okay. Yet another strategy.
You like switch up the order?
Seven and 9, same style, so, but, here's the thing that I know you guys are gonna wanna do, and it's not right. Can I get rid of that and put in cosine? No, because what's the identity? Sine squared. It's 1 minus sine squared equals cosine squared, or cosine squared plus sine, like, there's squares in it. So what's the strategy? What do you think the first step is, especially in number 7 and number 9? Valentina, what are you gonna say? What, multiply it out? Yes. Distribute. Do the multiplies. So fine. Group 5, 6, and 7, you guys get this. 8, 9, and 10, groups 1, 2, 3, and 4. So multiply stuff out. See what you get. Yep. I'm here at lunch. But I am more open to helping people if they actually do something in class.
Yeah, it's got some.
I'm trying, it's just like.
Yeah, I don't know that you're trying. I don't see any pencil's been put on that paper at all. Yeah. What are you saying we do?
Like, open parentheses, we got 1 plus sin x minus sin x and minus sin x squared. So we got sin x cancels negative sin x, so we got 1 minus sin x squared.
And then you say what, where, what? Then what?
And yeah, sin x and negative sin x cancels and 1 minus sin x squared.
The final answer.
Nope.
So we got cosine squared. X. Yes, we got.
Okay, so the first one, first times first, outside times outside, inside times inside, last times last.
It's the same
The
shit.
inside stuff cancels out, positive sin x, negative sin x goes away. And then Lucas says, then we get 1 minus sine squared x, then we gotta look at that Pythagorean identity that has the sine squared in it. 1 minus sine squared equals cosine squared, done. So, note, what would we do for number 8? What's the strategy? I need to turn tangent into its split up thing. It's sine over,
I just know sine.
okay? Looking at the front, what does tangent equal?
Cotangent.
1 over cotangent, that one doesn't help me.
Sine over cosine.
Tangent is sine over cosine times cosine, those guys cancel, so we're left with just sine. That one was pretty simple. So, Mache, how did you, what, distributing, what do we get when we do this stuff?
I go secant squared minus.
Okay, so he says secant squared minus 1. Because positive secant and negative secant cancel out. That doesn't look right. Lily, what, it's 1 plus tangent squared equals secant squared. So Lily, how can I, secant squared minus 1 becomes what? Subtracting 1 from both sides of that identity. She says this, I'm gonna get rid of this and put in tangent squared. Skip number 14, but the homework is through 15. We've done up to and through number 9. So if I check the homework tomorrow, I expect to see work on questions 1 through 15 minus 14. Because we just went over most of them. And the bell didn't ring yet either, so we pack it out?
No, I was gonna put it into my.
Okay, perfect, thank you, yes. They do not, unless it's multiplied on the top and the bottom, we can't cancel. Can I cancel those cosine squares?
No.
6 plus 3 over 3, does that equal 6? Does 9 divided by 3 equal 6? If it's added and subtracted, you can't just cancel things out. Emery, what about this? 6 times 3 over 3, can I cancel it out and get 6? That I can do. But when it's added and subtracted, no. Because what happens to the numerator?
Yeah, you wanna know more about cosine squares,
So Sophie, do you see the numerator sine squared plus cosine squared? Is there an identity that has that stuff? Equals
But
1.
does that work even though it's squared?
It has to be squared. So if you look at the identity on the front, sine squared plus cosine squared is 1. And then there's, Eliza, what's the name of one of her cosine squared?
Secant?
And don't lose the squared. I know you meant it, but you didn't say it. Emery, question? Emma?
Number 12, is like, so I made them into like cosine x, cosine squared x over sine squared x minus 1 over sine squared x. And it's just like,
So I would look at the identity that's got their names in it. So cotangent and cosecant are in the same Pythagorean identity. Can I move this stuff around? Like,
Oh, you could move like cosecant on it?
Well-
-1?
okay, so you subtracted the cosecant and squared and you subtracted the 1. So do I have exactly what I'm looking at?
yeah.
So what is cotangent squared minus cosecant squared equal? Negative 1. So it may take, it's not gonna be so easy always, like, this one, the identity is staring at me. That equals 1. This one, I had to take what I was given and mush it around a little.
Wait, what did you do to make the negative one on
Emma said, oh, well, in the given thing, so the stuff in purple at the top was what was the identity. She said, well, we wanted the cotangent squared positive, so she left that alone. She said, oh, maybe I'll subtract cosecant squared from both sides, but this was still hanging out, so subtract the 1. Yes, 14 is completely doable, but all of these have come out to be sine or secant squared. It's gonna be 2 things.
The negative cosine.
It's what?
Negative cosine.
It's gonna be 2 lumps.
I can check.
Okay, well, what did, what? So cosecant squared.
It's negative 1, I guess.
Could be that, or maybe I'll get rid of cotangent squared. And put this stuff in. up with two lumps of stuff. And which one do you want? I don't know. That's the problem with some trig identities is, well, where you like cotangent,
I guess I get one.
someone else might like cosecant. Emma? Okay. How would you start 13?
Well, I thought I was trying to go to.
Okay, well, I'll do it the really slow way. 1 over tangent squared is cotangent squared.
Oh, you know I can see this.
Cotangent is what over what?
It's cosine over sine.
So this is cosine squared over sine squared.
No, I said one. I said.
So this becomes 1 minus cosine squared
Sine squared.